Hello guys, welcome back to another video. So before I start, I will request everyone to please like the video, share with your friends and please subscribe the channel. So today we are taking another question of bit manipulation section, that is we have to count the number of set bits. So what this question actually says is that we are given a number n from the user and we have to count the number of set bits in that particular number n. Okay, suppose if we are given a number 4, we know that its binary representation is 100. So how many number of set bits are there? Only one number of set bit is there, that is 1. So similarly for number 6, how many set bits are there? 2 set bits are there. And for 10, similarly 1010 is the binary representation, 2 set bits are there. So let's start implementing this code. So first of all, we require a number from the user. So that's why what we have done over here is we have accepted the number from the user, and now we have created one function, that is void check set bits. Okay, now there was a famous mathematician whose name was Brian Kernighan, who proposed an algorithm which basically says that if we do if we take a number n and if we do the AND of that number n with number less than one less than that number, what this operation will do is that this will convert the last set bit of that given number n to 0. So what it basically says, or what it means is that, let me explain it to you with an example. Suppose if we are given a number 4, we know that its binary representation is 100. So if we do the AND of 4 with 1 less than that number, that is 3. So what it will do, AND with 011, we know the binary representation is 1011 for 3. So what it will do is that it will interchange, it will basically convert the last set bit to 0. So if we do the AND, what it is doing is that the output would be 000. So as you can notice over here is that our number was 100 and the last set bit was this one. So what this operation has done is that it has converted this bit 1 to 0 with the operation of this, that is n and n minus 1. Okay, so we are using the same logic over here. So let's see how this will work. So first of all, we will create a variable count which will basically count the number of set bits and initialize it to 0. Now what I will do, I will check if the number n, and if not if, what we will do, we will use that while n not equal to 0, what we will do, n is equal to n and n minus 1, and will increment the count to 1 and n right shift by 1. So let's see what is actually doing and see how it count. So let's see with an example. So suppose if we are given a number 10, okay, so we know that the 10 is not equal to 0, so it will come inside this while loop, and now this condition will encounter. So what this condition is saying is that n and n minus 1, we know that for 10 the binary representation is 1010, and for 9 we know that the binary representation is, for 9 the binary representation is, that is 1 0 0 1. Okay, so what it will do is that it will, what I have told you, that according to Brian Kernighan's algorithm, it will reset this last set bit to 0. So if we do the AND of this operation, if we do the AND operation, what it will do is that it will make this last set bit to 0. As you can see, yes, 1 0 0 0 0. And now what we have done, we have incremented the count to 1. Now the count will be 1. Initially it was 0, now the count will be 1. Now it will right shift this number by 1. So our number would be, now our number is basically 101. Okay, 0101. Okay, yeah. So next, what our task is, we have to, this is actually what, this is actually in decimal it is 5. Okay, now what we have to do again, we have to, the 5 is not equal to 0, so it will again come into this while loop. So it will do the AND with what, number 1 less than that number. So this is 4 100, this is the, so this is 4. So if we do the AND of this, it would be 0 1 0 0. So Yeah, 0 1 0 0. So you are getting, what we are getting is actually not, we have to use this number 1 0 0 0. Sorry, my mistake. I was a bit confused that I am doing something wrong. So this is actually 8. So what I will do, I will do the AND with 7 0 1 1 1. So this would be, if we do the AND of this, we will get 0 0 0 0. Okay, so we will increment, first increment. So our initially our count was 1, now our count will become 2, and now we are getting 0. So we'll come out of this while loop and our 2 will get printed. Okay, so I hope you understood this logic. So let's now run this program and check. Sorry, I have to call this function, that is count. What is the name of this function? That is check set bits. Count set bits. Okay, so let's run this program. Let me clear the terminal. Let me run. Enter the number. Suppose 8. We know that for for number 8, the binary representation is 1 0 0 0. So there should be at least count of set bits should be 1. So yes, we are getting 1. Similarly for 10, we know that there are 2 set bits as we have done in our example. So there should be 2 set bits. So yeah, we are getting 2 set bits. For, let me take some another example. Suppose 16. Yeah, 16, for 16 we have 1 set bit. Suppose for 7 we have 3 set bits. Yeah, we are getting 3 set bits. So this is how we can count the number of set bits in a given number.